Hi and welcome to the video for Chapter 20 on hypotheses tests for proportions. Today we are going to focus on large sample 1 proportion z-tests and all that those things entail. So let's get started. So first let's talk about what the hypothesis test is really going to have us look at. So what are they? Hypothesis tests are calculations that tell us if a value occurs by random chance or not, and if it is statistically significant. And again, the statistically significant is what we're really going to look at with our test. Excuse me. So there's two things that we really need to think in the back of our head when we've got our data, we've sampled it, we've collected it all, we look at what our answers are. Now the answer, hopefully when you go through and you'll go back to your alternative hypothesis and you're thinking, well, did I prove it or not? Did you prove it because a random occurrence that happened to your data due to some type of variation, like all of the things kind of fell into place and that's the reason why your answer's the way it is? Or maybe it was a biased occurrence that's due to something that, I don't know, whatever other reason that could have happened. So again, you're thinking back of your statistic of what you're finding and you're checking to see if it's random or not and if it's significant. And we'll talk a little bit more about that when we get to our levels. All right, so let's take a look at the nature of the hypotheses tests. So H sub O. First, we begin by supposing the effect is not present. I know it sounds kind of strange that we're looking at something that's not present, but that's how you start your null hypothesis. You look at the status quo. You look at something that has no effect, that nothing's out of the norm. And then we see if the data provides evidence against the supposition. Now, like I said, it seems kind of strange this way, but when we get to our numbers, you'll hopefully see why. Excuse me. So I tried to think of an example in real life that would really correlate to that, and I thought of a murder trial. So you have a suspect who has done this crime, or is suspected to have done this crime, and they go to trial. So you have this suspect who's assumed innocent, right? That's the norm. We're all assumed innocent. And then the prosecution's job is to try to prove that he's not innocent. So again, it directly correlates to what we were just talking about. So how does that trial work? So again, you're assuming that the person is innocent, and then you must have sufficient evidence to prove guilty, aka not innocent. So again, hopefully you see that there's a correlation between our hypotheses tests in this example, since it's the same type of process. Okay, so let's talk about our 5-step process. It should look familiar, being that on Wednesdays or our chapter 19's notes, we had the same type of thing. Although we had 4 steps in that, although there really truly is 5 because our calculations also does show work. But in this here, we are adding in this one extra step compared to what we did before in chapter 19. So here, we're adding in our hypothesis statements. And hopefully you learn those today. So let's talk about writing those. Now you have 2 of them that you must write. The first one, and always the first one, is your null hypothesis. Now this is a statement that is being tested. This is a statement, again, like there's no difference, there's no effect, it's the status quo that's supposed to happen. And again, it's denoted by H sub O. Now, likewise, the other thing that we're supposed to write with our hypotheses tests is the alternative hypothesis. And that is simply the statement that we suspect to be true. It's denoted as H sub A. Right, so there's some forms that we have to kind of make sure that we follow. Your null hypothesis is written H sub O and there's a colon. You're going to write whatever your parameter is. Generally it's P. And you're always going to have an equal sign. And then you're going to have some value. And that's always how it's going to be. You're going to have H sub O colon P equals and then whatever. Now, the alternative hypothesis is a little different. There's 3 different scenarios we have to go through. You could have your parameter greater than your hypothesized value. And again, this is when, think about your norm. You're greater than. So you can have your alternative hypothesis kind of proving that it's greater. So like, let's say that in January, my bank account had so much money in it. And hopefully by December, it's going to have more. So again, we have my hypothesized value, my parameter is going to be more than that. Okay, so here's another example. This is the second type of alternative hypothesis we can have. You can have your alternative hypothesis where the parameter is less than the hypothesized value. So there was a certain number of students who failed midterm. Hopefully by the end of the year, that number is lower. So again, my parameter, the people who failed the class, is lower or less than the hypothesized value from midterm. And when you're talking about less than, that's less than the norm. So it's going to be to the left. And then you have not equal. Now, not equal, again, this is a little bit more difficult to prove, in my opinion, in that you have to show both. So again, make sure that you're always referring back to your populations, your parameters, when you're talking about your hypotheses. All right, so let's look at the correct way, or things that are legitimate or not legitimate in the way that we write our 2 types of hypotheses. So take a look at A. Can you or are you allowed to write P is equal to 15% for your null hypothesis, and your alternative hypothesis is also P is equal to 15%? No, they're not allowed to do that. It must be equal or not equal. So again, we had 3 different cases that we were talking about. So this is the only one. Your H sub O is the only one that should have the equal. H sub A cannot have the equal sign. So no, it doesn't work. It's not legit. How about B? H sub O, where P hat is your statistic. You have your statistic is equal to 12.3%, and your alternative hypothesis is P hat is less than 12.3%. So the form is equal and less than. Are we allowed to do that? No. Again, you're not allowed to use the statistic sample here. You are not allowed to use P hat. You must use P, your parameter. Likewise, how about C? If you have your null hypothesis at 10% and your alternative hypothesis not at 10%, yes, you are allowed to do that. What about D? Your null hypothesis is 40% and your alternative hypothesis is greater than 60%. No. Now the reason why, again, you must have the same value. And it really doesn't make sense if you're trying to talk about this here as your null hypothesis. Your alternative hypothesis it has to talk about the same percent. If you're not, you're talking about something different. And again, you can't do that. And lastly, letter E. Can we have our alternate, or excuse me, our null hypothesis not equal to 50% and our alternative hypothesis equal? Hopefully you see that no, we're not. Again, it falls apart with your null hypothesis having the not equal sign. You must have an equal sign for your null hypothesis. So I'm going to pause here and go to our next video in just a moment.